In this video, I'm going to talk to you about how you choose the best method for solving a quadratic. And there are 4 methods that we learned in my class. One of them is called factoring method. Another one is called square root method. Next, completing the square. And then last, quadratic formula. And so I want to talk to you about kind of the flow chart that I use to help you decide. Before we start anything, I want to make sure that you have your function in standard form. And so that's not one of the methods of solving, but that's first just start with standard form. And then this is how I go through the process. Can I factor easily? And I mean that easily. If yes, factor and set your factors equal to 0. It's a quick, easy way to solve. But again, if factoring is easy for you. Then next, if factoring's not easy for you or you just can't figure it out, then what I would say is look for the middle term. The middle term meaning the linear term, the bx term. If that term is missing, then use the square root method. And then don't forget when you apply the square root, apply your plus and minus. Now, if your front term is 1 and b is even, if those two happen, let's say you're not missing your middle term, or factoring is not easy, so you're kind of moving down the chart. If your a is 1 and b is even, then I would complete the square and solve with the square root method. What you want to remember is you're going to take half of your middle term, you're going to square it and add that to both sides, and then you're going to solve by square root method. And then last, if none of those things work, then my last resort would be to use quadratic formula. And so I'm going to go through a few examples with you. Actually, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to do 10. And I'll probably cut it up 5 examples per video, just kind of so they don't get incredibly long and then you don't have tons of videos to watch for this section. But choosing the best method, let's go. For the first example here that I see, I notice that I have 1x squared minus 5x minus 14. So my first method of choice would be to try to see if factoring is easily done. And so what I'm looking for is what 2 numbers multiply to make negative 14 and at the same time add to make negative 5. And I'm pretty certain I can pick out that pair. If we had a negative 7 and a positive 2, those are going to multiply to make negative 14. And negative 7 plus 2 will add to make negative 5. So the method I'm going to choose is factoring. And again, because it's easy. And so I'm going to say it was easy to factor. So now I'm actually going to factor it and solve. So my x minus 7 is a factor. The x plus 2 is a factor. And now to solve by factoring, set each factor equal to 0. So x minus 7, set that equal to 0. And one of my solutions will be positive 7. And then my other factor, set this one equal to 0. And my solution will be negative 2. So 2 solutions here, and factoring I did because it was easy. Now in my next example, I have 3x squared plus 15 equals 0. I notice that my bx term is missing. And so again, this is just going off of my flow chart here. Am I missing the middle term? I'm going to use then square root method. And so I'm going to pick square root method. And then I'm going to say here, isolate your x squared term and solve by taking the square root of both sides. And I'm going to also remind myself, don't forget, if you apply this sign, don't forget the plus and the minus, because I know that sometimes happens. So isolate the square term by subtracting 15 to the other side. And I have 3x squared is equal to negative 15. And now I'm going to divide both sides by 3. Negative 15 divided by 3 is negative 5. And now what I'm going to do is apply the square root on both sides. Now the square root of a negative, this is going to end up giving us no real solution. But if this was a positive, we just state what that answer was. I'm going to put no real solutions. All right, moving on. I'll do 3 more examples in this video. So here I have x squared minus 14x plus 16. And I'm noticing that, to me, factoring looks like it'd be kind of hard because I'm thinking of what numbers multiply to make 16, an 8 and a 2, a 4 and a 4, 1 and a 16, none of which, in my opinion, will combine to make 14. And so that's going to be a little too challenging. So not factoring. My middle term is not missing, so I'm not going to be able to do square root. And so I'm going to do what is called completing the square because I have my lead term is 1 and my b is even. So I'm going to write complete the square because my a is 1 and my b is even. All right, so now what I'm going to do is move my constant over to the other side. So I have x squared minus 14x will equal now negative 16. We take half of the middle term, which is going to be negative 7, and then I'm going to square that number. And then I'm going to add 49 to both sides. So x squared minus 14x, I'm going to add 49 to both sides. And now I'm going to factor this really easily. What 2 numbers multiply to make 49 and add to make negative 14? That number that you halved goes in here, and it makes a perfect square, which is why it's called completing the square. And then 49 minus 16 for this side is going to get me 33. So now I can apply the square root to both sides. And don't forget that we want a plus or minus here. And I'm going to get the decimal for this. So square root of 33 with my calculator is roughly 5.75. And then I'm going to add 7 over. So I have x equals 7 plus or minus the square root of 33. But if I use the decimal here, clear, 7 plus 5.75 is going to get me 12.75, and then 7 minus 5.75, because I'm adding and subtracting that, I get 1.25. So these are going to be my 2 solutions, 2 places where my parabola is going to cross the x-axis. Okay, now here is another example. I noticed right away that I don't have a cube term, but I do notice that there is a greatest common factor that all of these have in common, and I'm going to divide by the GCF of 2x from each of those terms. So I'm going to take out a 2x factor. I'll be left with 1x squared plus 11x plus 10. And I want to see if this is factorable. 2 numbers that multiply to make 10 and add to make 11? Oh, for sure. That's easy. Multiply to make 10, add to make 11. It's going to be a positive 10 and a positive 1. So I'm going to choose factoring. But again, because it was easy. And so y, easy. And then now set each factor equal to 0. And then solve. Okay, so we're going to set each of these factors equal to 0, and we'll start here. 2x, if that's equal to 0 and I solve by dividing by 2, one of my solutions is going to be 0. If I set x plus 10 equal to 0 and I solve by subtracting 10 on both sides, I'm going to have x equal to negative 10. And if I set x plus 1 equal to 0 and I subtract 1 on both sides, another solution would be negative 1. Okay, here we go. Last problem for this video, and then I'll start another video for the last 5 problems. I noticed that my middle term is missing here, so I'm going to use the square root method. So my linear term is missing, so I'm going to isolate the square term. and apply square root to both sides. Okay, so I'm going to start by isolating the square part, and I get x squared is equal to 36. So now if I apply the square root to both sides, a square root is going to undo a square. And the square root of 36, oh, I know that, it's 6. So I'm going to have two solutions, a positive 6 and a negative 6. And that's the end of this video. Stay tuned for one more video on 5 more examples on how to pick the best method to solve a quadratic.